So in this video, I'm going to solve the equation 2 to the power of x plus 1 is equal to 2024. So to solve this, I'm going to first start by dividing both sides by 2. So 2 to the power of x plus 1, well, I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So turn this into 2 to the power of x times 2 to the power of 1. So this is what 2 to the power of x plus 1 is equal to. So now I have 2 to the power of x times 2 to the power of 1 is equal to 2024. And if I divide both sides by 2, these two cancel out. And I get 2 to the power of x is equal to 1012. Now, I'm going to add 1 on both sides. So I get 2 to the power of x plus 1 is equal to 1013. So this is the value of 2 to the power of x plus 1. Now, going back, we know that 2 to the power of x is equal to 1012. So to solve this, I'm going to take the log on both sides. So I get log 2 to the power of x is equal to log of 1012. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So in this case, I can move x to the front, and I get x times log 2 is equal to log of 1012. Now we want to isolate x, so I'm going to divide both sides by log 2. So these two cancel out, and I get x is equal to log 1012 over log 2. And if I plug this into a calculator, log of 1012 divided by log of 2 log of 1012 is equal to 3.005. So I have this over log of 2 is equal to 0.203. So 3.005 divided by 0.20 is equal to 14.803. So this is my answer.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out, so we're left with 3 equals 0 plus x is x. So now we have our value for x. Now why don't we go ahead and plug it in to our equation. So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0. Equals 1, and remember, anything to the power of 0 equals 1, so 10 to the power of 0 equals 1, so we have 1 equals 1, and this is right, meaning our answer of x equals 3 is right.